Patient monitoring using Internet of Things. Abstract. Nowadays IoT is playing an important role in healthcare systems, which is not only helpful for monitoring the health parameters but also helpful for communicating, storing, and displaying the monitored data. The main aim of the project is to design and implement effective healthcare patient monitoring system. The proposed system monitors the health parameters like temperature, BP, and pulse rate etc. and then transmits the parameters wirelessly through Wi-Fi module technology. The transmitted data is displayed on the PC. This data gets updated into database continuously. From the database with the help of Android application fetches all the updated data and displays it on doctor side personal mobile. This tells the doctor the current status of the patient in real time. If any parameter of a particular patient goes beyond a pre-assigned threshold value, then an automatic notification will send on doctor's mobile using Android mobile application. The system basically consists of hardware like sensors, microcontroller, Mqtt 16, LCD display Wi-Fi module, ESP8266, Mqtt Protocol for sending data on cloud, Android app etc. 1. Introduction. Internet of Things, IoT, dependent patient monitoring is a network implemented to operate different medical sensors connected to the human body. Implementing it in medical application gives flexibility of operation. They reduce user discomfort and enhance mobility. Applications in this category include monitoring of the biological parameters, tracking and monitoring of the patients inside hospital. Applications in this category include monitoring of the biological parameters, tracking and monitoring of the patients inside hospital. Proposed system is a special purpose network designed to operate various medical sensors connected to the human body. They measures body's basic functions which can be helpful for monitoring general health of a person. The aim of the healthcare application is to provide better healthcare to all the people anywhere and at any time, and purpose of the system is to prevent delays in the arrival of patients' medical information to the healthcare providers, especially in accident and emergency cases. Basically the flow of system is based on medical sensors that measure patients' physical parameters with the help of wireless sensor networks, WSNs. These sensors transfer data from patients' bodies over the wireless network to the cloud environment. Cloud environment gives suitable and on-demand network access for number of computing resources such as networks, systems, applications, and services. The proposed system consists of following component. Sensing node. Each sensor node is connected with a microcontroller and a power source. The sensors will require limited source of energy. The sensing nodes will sense physical data, then monitor all conditions, and performing small processing operations it will transmit data to other sensing nodes and network. Transmission technology. Transmit data over network through Wi-Fi module with the help of message queuing telemetry transport, Mqtt Protocol. 2. System description. 2.1 System block diagram. The block diagram of patient monitoring system is shown in figure. Here 3 IoT biomedical sensors named as temperature sensors, blood pressure sensors and pulse rate sensors are connected to AVR controller. They will sense medical parameters with respect to the 3 sensor, then with the help of Mqtt, message K telemetric transfer, publish subscribe protocol the information of the patient is sent on cloud through Wi-Fi module and using Fig 1 block diagram of patient monitoring system. 2.2 Methodology of implementation. In proposed system, 3 applications have implemented. These are as follows. A. Data collection. B. Data on cloud. C. Decision-making process. A. Data collection. Patient's physical parameters are measured using medical sensors that are connected to a microcontroller. It is responsible for collecting data from the sensors and transferring it over router to the cloud environment. The sensors transmit real-time data in the cloud continuously based on the set conditions which are in their configuration program. The DS18B20 digital thermometer gives 9-bit to 12-bit Celsius temperature measurements. The DS18B20 communicates over a one-wire bus, requires only one data line and ground for communication with a central microprocessor. In addition, the DS18B20 can take power directly from the data line. It does not require external power supply. Blood pressure is the pressure of the blood in the arteries as it is pumped around the body by the heart. When your heart contracts and pushes blood through the arteries to the rest of your body, force creates pressure on the arteries. Blood pressure recorded as 2 numbers, the systolic pressure, as the heart beats, over the diastolic pressure, as the heart relaxes between beats. B. Data on cloud. Here Mqtt Protocol suite is used. It is a publish-subscribe type. Mqtt broker will act as mediator between publisher and subscriber. The publisher will send or transfer the information regardless specific receiver. Receivers are categorized and receive information according to topic. The Mqtt messages are delivered asynchronously, push, through publish-subscribe architecture. The protocol works with the help of exchanging a series of Mqtt control packets where each one has a specific purpose and every bit in the packet is used to reduce the data transmitted over the network. Client and server communicate over different control packets. Steps to connect Mqtt server are as follows. Step 1. Download an application named Mqtt Dashboard on Android phone. Step 2. Open application and go to settings. A. In first text box enter client ID. B. In second text box enter URL of Mqtt server/client, that is iot.eclipse.org. C. Third text box is for port, type 1883. D. Left username and password blank. E. Press create. Step 3. Now you have to create a topic in phone. Step 4. To subscribe to the topic on phone, you have to type the topic name in phone, which is patient 1. In such manner connection with Mqtt server is completed. For sending the data on cloud along with Mqtt protocol we have used Wi-Fi module ESP8266. The ESP8266 is low-cost Wi-Fi microchip with full TCP/IP stack and microcontroller capability. This small module allows microcontrollers to connect to a Wi-Fi network and make simple TCP/IP connections. Basic flow chart. D. Decision-making process. Here sensor will sense the data that is human bodies. Medical parameters such as temperature, pulse rate, and blood pressure. If the data is normal then it is saved in database and it will send decision to doctor's follow-up. Now if the is not normal then it will check medical condition. The result is sent for doctor's approval for further treatment. 3. Decision approval. After the system makes the decisions, it will be sent to medical staffs for the patient's healthcare for approval. There are different ways to notify medical staff including SMS and email. They can use a web browser from any device to review and update decisions as needed. Medical staff can decide if the current decision which are created from the system are right for the patient's condition or they need to change and update them. 4. Experiments 4.1 Results. This section describes results for patient monitoring system using IoT and then experiments which we have performed for performance calculation of implemented system. Following figure shows that the results on LCD and Android app. In the result following parameters are shown: temperature, motion, and position of animal. LCD output. 2. Temperature output. 3. Pulse rate output. 4. Blood pressure output. Above table 4 to 6 shows human's basic body parameters that are the temperature, pulse rate, and blood pressure parameter with different conditions. V. Android app output. 2. Performance parameter. 1. Percentage error measure. To calculate the performance of the system, we have to use a percentage error measure. It is the difference between a measured value and an expected value. The formula for percentage error is as follows. From above 3 table values, percent error of temperature sensor calculated as for reading number 1. For reading number 2. Similarly, we can calculate percent error of pulse rate sensor and blood pressure sensor. 2. Accuracy. Accuracy measures the ability of design system to detect the true value or expected value with respect to the given condition. The formula for calculating accuracy is as follows. From above 3 table values, percent accuracy of temperature sensor calculated as for reading number 1. 5. Conclusion. In this paper we proposed a framework for patient monitoring using Internet of Things, which used to transmit the data which is sensed from biomedical sensor to the server by using Wi-Fi module. It is completely integrated so that it is possible to measure human body's basic parameter anytime from anywhere. It has real-time capability. The accuracy of system is affected by some factors such as time delay, network around the mobile, GPS receiver having accuracy is 93.33% and sensitivity of system is 93.33%. Circuitry is having less complexity and modules used are smaller in size and also lightweight and portable.